Honors Algebra 2. This is Chapter 5, Day 5. We're going to talk about graphs of a quadratic function using our friend the discriminant. So this is going to be a very fun lesson for all of us. It's going to save us from using the quadratic formula over and over. We're going to actually just use the discriminant to be able to tell how many solutions a problem will have. So quick reminder, this is the discriminant. It's the part under the square root in the quadratic formula. So quick reminder, quadratic formula, negative b plus or minus square root. Here comes our discriminant all over 2a. So I'm talking about just this portion under the square root. I can use just that portion to find how many solutions I have. A couple problems is, what if the discriminant is greater than 0? Then there are going to be two solutions. Okay, you will know this if you actually solve the quadratic formula. You would get plus or minus the square root divided by 2, and you'll see there'll be two answers. If the discriminant equals a perfect square, so let's say it equals 25 or 36 or 64, whatever, as long as it's a perfect square, solutions are going to be rational. If they're not perfect, let's say it's the square root of 20. Well, you can't simplify that perfectly, so you will have a square root, which means your answer will be irrational. Hopefully that can be an A. Come on. A nice A for irrational. There we go. Okay, if the discriminant equals 0, you're going to actually have one rational solution. And you will be able to tell this once you solve the quadratic formula to verify, but this is a known fact that we can use. If the discriminant is less than 0, that means under your square root is a negative number. You should know it's going to be two imaginary answers. And we're going to talk about how these look today. So there'll be two imaginary solutions. Okay, because you'll be taking a square root of a negative number. Let's give it a try, my dears. So we're going to find the discriminant without actually solving this equation. So don't do quadratic formula. Let's just use the discriminant. We'll tell the number and kind of solutions there will be. If there are real solutions, let's say if they're real or irrational. Okay, so we're just using the discriminant. So all we need to do is plug in to b squared minus 4ac. And this is going to tell us everything we need. Quick reminder, the coefficient in front of your squared term is a. The coefficient in front of your x is b. And your constant is c. And it does have to equal 0 in order for you to pick your A, B, and C. So I'm going to call it D equals, like the discriminant equals. My B value is negative 5. My A value is 3. C value is 6. Doing this math, I get 25 minus 72. So my discriminant is negative 47. We're going to use this now to tell how many solutions we have. Heading back up here, if the discriminant is negative, less than 0, we're at our last step here, it's going to be two imaginary solutions. Because I can put an S there, right? Two imaginary solutions. So tell me that. You found the discriminant. Now tell me you're going to have two imaginary solutions. Let's try our next one. Again, we're going to use our discriminant. We're going to plug into our discriminant equals b squared minus 4ac. But this time I can't just use the a, b, and c there because it does not equal 0. So first step I need to actually do is move over that negative 15. So I get a positive 15 it now equals 0. So now I can have my A, my B, my C. Really very small step, but it will make or break your answer. So let's plug in. B is negative 13. A is 2. C is 15. When you simplify, I'm getting 169 minus 120. So I get my discriminant to be 49. Now, using what we have above, let's figure out how many solutions that is. Well, it looks like the discriminant's positive, so it's in this first case. Looking at it, if b squared minus 4ac is a perfect square, which it is, 49 is a perfect square, I'm going to have two solutions that are actually going to be rational. So I'm going to actually just add in right here, guys, sorry. No, actually I'm going to leave it. Change my mind. We'll do it like this. Okay, so I will have two rational solutions because it is a perfect square. This will be two rational solutions. Okay, this will save you a lot of time, a lot of errors with quadratic formula. Just use discriminant to find the types of answers. Now our second part of our notes today is about imaginary and complex numbers. So this is where it is negative under the square root. This is how we're going to be handling it. These two equations right here are beyond important. Okay, you always need to simplify these to be what they're equal to. So if I ever have a square root of a negative 1 in my answer, right away, you have to make it I. Okay, you never leave a negative square root in your answer. You would leave an I in your answer. Similar, you would never leave an I squared in your answer. You would always put negative 1. Okay, we'll walk through a couple examples, but please, 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 that is super important that we understand. So when we're simplifying a square root with a negative sign, normally we would say no solution, not possible. But now we're going a little bit deeper. We're going to simplify this by breaking it up into the square root of 36 times negative 1. Okay, this is equivalent. You then can break it up into the product of two square roots and simplify each one. The square root of 36 is 6. Looking at above, square root of negative 1 is I. So you just simplify it like that, and voila. That's my final answer. Let's try one more. First step is we're going to separate it to be 24 times negative 1. These are equivalent. You can now break it up into the product of these two square roots. Square root of 24 sadly is not perfect, but we can keep breaking that into square root of 4, square root of 6. The reason why we do that is we're going to simplify that square root. The biggest perfect square is 4, so it's really 2 square root 6 times, again, this is a conversion. We have to remember that square root of negative 1 is just I. You will never see it left like this, 2 square root times I. Please, please, please move the I in front. Sometimes people have the tendency of making it look like it falls under the square root if you leave it at the back. So please put it in the front, 2I root 6. Make it a little bit smaller. But you'll do that for every negative square root. Now our next little vocab is complex numbers and complex conjugates. We know what a complex number is from, I believe, day 1 of this whole year. it's a plus b to the I, or a plus bi. Sorry. The conjugate is when you actually flip the sign in front of the imaginary value. So instead of it being 5 plus 3i, the conjugate would be 5 minus 3i. Notice the 5's are still positive. It's only the imaginary values that flip their sign. Okay. The reason why we're going to use this is when we are simplifying, we cannot leave an imaginary in the denominator. Think of like you can't leave a square root in the denominator. So what we're going to do, for example, if it is like 1 over 5 plus 3i. Well, we need to get that imaginary out of the denominator, so you would multiply it by the conjugate, which just means you flip the sign in front of the imaginary. And I'll explain a little bit further what that's going to look like, but this is what the conjugate is. You flip the sign in front of the imaginary value. Then you'll FOIL at the bottom and it will actually go away. Okay, the next part, or I guess your classwork, will be this Making Practice Fun number 45/46 worksheet. I'm going to take a couple examples from there. This homework assignment is in the practice folder. I'm going to pick just random problems to talk about, and then you'll be able to finish that worksheet. So for example, I'm going to pick number 1. Please try number 1 on your own. Okay, welcome back. Hopefully you tried it. Let's see how you did. You're going to break it up into 2 radicals like so. Right, these are all equivalent. Square root of 25 is a nice 5. Remember, this simplifies to I. Hopefully you did good on that one. Next one I want to talk about is number 8. So here's number 8. Please pause the video, try this problem, and let's see how you did. Okay, hopefully you paused. For this problem, you're multiplying negative 5i and negative 3, which means you'll multiply your coefficients and get positive 15, and I is multiplied by 1, so you just get your 15i. Okay, treat it like it's an exponent. It just comes along for the ride for this problem. Next one, let's try, how about number 9? So that's square root negative 7 times square root negative 14. Please pause and try this one. Okay, hopefully you tried this one. What is special about this is you actually cannot just multiply underneath. Okay, you cannot do that with negatives underneath the square root. So if you did that, please cross it off. Leave it, but cross it off and say, oh wait, yeah, we can't do that. You'll notice when we simplify here, this will be square root 7, square root negative 1, times square root 14, square root negative 1. Here we're pretty much simplifying them separately. So this would be square root 7 times I, square root 14 times I, right? Because this simplifies. Whenever you have this, you have to simplify it. I will rewrite it, please, 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 with your imaginary in front, because sometimes it gets a little underneath that square root and that would not be correct. Now we're going to multiply these 2 terms. Similar to when we multiplied square roots before. Whatever's outside, you multiply together, so you'll get I squared, and whatever's underneath the square root now, you can multiply, because those are positive numbers. Okay, at the beginning we couldn't do that because it was negative 7 and negative 14. So I'd get square root 7 times 14, 98. Okay, now we have an I squared. Look back up at the top. If I have I squared, you need to simplify that to negative 1. Okay, that's from above. Let's simplify this square root. I believe it's 49 times 2. Yep. So I would get negative 7 root 2. That is the final answer for number 9. Please make sure you got those steps. Let's do a couple more, 2 more. How about we try number 20? So number 20, 3 minus 2i subtracted by 3 minus 13i. Pause, give it a try. Okay, hopefully you did that. The biggest thing you have to remember is to distribute 3 minus 2i minus 3 plus 13i. And now you combine like terms. 3 and negative 3, well, they cancel. And then negative 2i and 13i come together to be 11i. Okay, so it's like combining like terms. And then you're good to go. One more, okay? Let's just have fun. We'll do number 25, and then the rest is yours. And I'd be happy to talk through others. So the problem is 2i. But the directions, I believe, say... I'm going to pause for a second. Directions for this. Directions for number 25 read. Oh, sorry, I'm in the other section right now. So this is on the back side. This is find the reciprocal. Well, reciprocal means flip the numerator and denominator. Okay, that's the reciprocal. So the reciprocal is 1 over 2i. Oh, but bummer, we can't leave an imaginary in the bottom. Well, this goes back to what I just mentioned above about our complex conjugate. Let's get rid of that in the bottom. So that means I'm going to multiply the top and the bottom by the opposite sign of my imaginary value. So it's going to look like this. Multiply the top, multiply the bottom. Oops, I have an I squared. That's positive, right? I need to change that. So really, it's negative 2i over negative 4 times negative 1. Right? My goal is to get rid of that imaginary in the bottom, which is good. I can exchange negative 1 with I squared. So as you simplify, you realize it would be negative 2i over 4. Simplify that, you get negative I over 2. Okay, that is the reciprocal. It is no imaginary in the bottom. So I just jumped around on the Making Practice Fun number 45 and 46 page. So please take a look at these and good luck.